If you work in security or IT and your company has Okta, this message is for you. Imagine a world where only secure devices can access your cloud apps. In this world, phish credentials are useless to attackers, and you can manage every OS, even Linux, from a single dashboard. Best of all, you can get employees to fix their own device security issues without creating more work for IT. The good news is, you don't have to imagine this world. You can just start using Collide. Visit securityweekly.com/Collide to watch a demo today. That's securityweekly.com/KOLIDE.
Hello and welcome. I'm Sean Metcalf with Security Weekly, and I am here at Black Hat Live on day 2 with Raghu Nandakumara. Hopefully I said that correctly.
Perfect.
Senior Director, Head of Industry Solutions at Lumio. So thank you very much for joining me. First thing I want to ask is, your company is focused on zero trust, and there's a lot of people that have a lot of ideas or thoughts about zero trust, and traditionally it's been another way to just do microsegmentation on-prem. So tell me a little bit about how you see zero trust and how Lumio kind of approaches this challenge.
The reason I'm laughing is because I just love talking about this. So Sean, thank you very much for having us here on your show. Zero trust, right? Firstly, when I think let's start with misconceptions, right?
Yes.
So when people hear about zero trust, right, the first thing is like, zero trust, how can that be possible, right? No trust means, then how do I function without a concept of trust, right? So I think zero trust, if you just take it literally, it's probably not the best term.
Right.
But the way I think about it is zero trust is actually the reduction of implicit trust in the environment, right? So if you contrast that with sort of how historically we've built sort of our environments, is that we have sort of like the threats, everything bad is on the outside, right? And everything on the inside that I've vetted, validated is trusted. So I have that perimeter and I say inside trusted, outside non-trusted. But what we've seen, right, is as we have more and more things on the internal network, right, we then connect in whatever third-party managed environments, cloud, right? We move our endpoints and users, not just into that sort of from that campus, but for everywhere, right? That assumption that everything that is connected and accessing things is fully trusted just is destroyed, right? So then we've got to reframe and think, okay, well, how do I approach this? If I start from the principle that I can't guarantee that everything is attached to my environment, I can be fully trusted, how would I build security, right? And then also like we talk about assume breach, right? Which is also parts into this. It's essentially, right, if I assume the unexpected, then how would I build security? Well, if you did that, then you'd say, okay, well, I want to be able to validate this thing, right? When I say thing, I use that as a general term to mean user, device, application, whatever thing is, right? I ensure I validate it, right? I give it some kind of context, and I build my security policy based on that context, right? So, and that way, if that asset, let's say it's like an easy example is, let's say a user on an endpoint. The user endpoint moves from their home office to their Starbucks. That context changes. Maybe they get access to different applications. They then come on to the campus and attach the corporate network. The context changes. They get a different access, right? That is zero trust, right? Providing non-implicit, context-based access, right? So that as much as possible, you can only access what you actually need to, right? And that I guess that last part is sort of the ultimate goal. If we can get to a point where we can only ever access what we need to, that's excellent.
When we need to have that access.
When we need to have
right?
access,
yeah.
Exactly.
I think the challenge that we've had is that, to your point about zero trust and how it's like, how do you get to that point, is we've had all trust all the time. And flat networks from the very beginning, basically, we've said everything connect to everything. They just always communicate. And so there's this concept or idea around zero trust where nothing is trusted, but everything will just automatically connect to what it needs to and have that access, right? And that's the challenge, because when you have assume breach, as we talked about on the network, and then we went through 2020 and 2020, and everyone is everywhere. Like you said, not just Starbucks. They're at home, or they're at a hotel somewhere, and maybe here in Vegas. How do you ensure that they still have the appropriate access when they need it, when they're supposed to,
exactly,
and then it's not being impersonated? And
absolutely,
that's the challenge.
That's absolutely the challenge, and it's also a bit of an emotional challenge. because again, that concept of trust, like for humans, trust is such an important thing, right? And then when you say zero trust, it's like, okay, why are you not trusting me? But I think the way we should also think about it is that from an effort perspective, right? In order to maintain a fully trusted environment all the time, the effort is significant, right? Every single thing just from the building blocks of the network itself to everything that you then deploy on top of it, the server, the operating system that's running on the server, the application that's running on there, the user that it's accessing, every single thing you have to go and validate, and all the agents, and then the patches, you have to be able to manage that. But here, actually, by adopting zero trust, you're allowing yourself to have a far more dynamic, productive environment, and done properly, it's an enabler for business productivity, right? And delivering better security.
So I like that approach. And one of the things that you've talked about before is this concept of you're not just in the home office, you're at Starbucks, you're somewhere else. And now we have cloud services. So we have cloud workloads as well. So it's not even a situation where we're really just talking about on-prem, or I'm sorry, in the office or out of the office. It's in the office, out of the office, in the cloud, in some other place. So how does Zero Trust expand kind of that mesh concept to cloud services?
Well, we were talking off air about this, right? I don't see, so we absolutely and rightfully make a big deal about cloud security, right? But from my perspective, cloud security isn't massively different to how we consider on-prem security. It is just an extension of that, right? So whatever we have considered to be sacrosanct, important for how we build security and the sort of like the foundations, right? Or the must-haves or basic security building blocks, whatever you want to call it, those fundamentals are just as important in cloud, right? With the kind of added key differentiator being that anything in cloud is one misconfiguration away from being accessible to the whole wide world, right? And if you think about the history of cloud breaches, right, it is that one little thing, right, literally one bit in a configuration that has meant that you suddenly have your world-readable S3 buckets, right? So I think so zero trust, right, removing implicit trust is important everywhere, but especially so in cloud where you're exposed straight away if you get that wrong.
Yeah, I like the approach that you have and what you talked about from the context. Because for me, I think it's always important to understand what the context is to it. Whether a user is connected into a VDI, whether they're on their laptop, in the office, or at home, or they're or connected to some sort of cloud workload, that context is important to determine what sort of access they have, and maybe even when they're allowed to have that access, especially in a world today where we see these administrative credentials getting stolen all the time. So a lot of companies are very concerned about how to best control not just the access that the person who is the administrator for the system, but also in which context they are allowed to have that access. Are they allowed to connect from a regular user workstation, or are they only allowed to connect from an admin system? So what can you talk about with Zero Trust, how that might help that sort of scenario? I mean, it kind of touched on it, but maybe you could go a little deeper.
Yeah, it touches on it, right? Because I think you talked about sort of like permissions, right? And then you also talked about sort of access from being possible from one particular system, the Bastion host, the jump host, versus not possible from their sort of generic VDI, right? And I think that's like, you've just kind of, without saying those words, you've just really described a context-based policy, right? So you've essentially associated context with the VDI versus with that jump host, with that Bastion host. You've associated some kind of permissions based on context, based on the role of the user, right, with the administrator versus the general user. And again, right, it's this beauty of kind of as your deployment matures, being able to combine the context of the user with the context of the device, with the context of their location. So these things don't need to be discrete, right? I think the way we've built security is, okay, you've got identity and access management, right? That protects sort of the user. You've got sort of network security that protects the network. You've got what you do on the operating system to protect the operating system. But I think Zero Trust, right, sort of as that matures, really brings that all together.
Right, because each of those are siloed and they're disparate systems.
Absolutely.
Usually totally separate. And
absolutely.
So from what I'm hearing, your concept of Zero Trust, when it's done correctly, is basically normalizing across those different silos and in providing a central mechanism to ensure controls throughout those.
Yeah, absolutely.
Especially when you have Azure and AWS and GCP all have different IAM, identity access and management systems, right?
Yeah, absolutely. And when we think about this, right, from our perspective, we are focused on sort of segmentation, right? So Illumio, the Zero Trust segmentation company, so we're really looking at applying sort of those principles of Zero Trust to really protecting interactions between resources in your interconnected environment, right? So the context that we are talking about, right? So while ultimately the way we instrument the control is limiting access or between, let's say, two workloads. And workloads, I kind of use, again, loosely, it's essentially anything that is connected to your network with some kind of sort of, it's visible on the network, right? But you can associate it, all of those kind of parameters, those bits of context, right? What is the user on this workload, right? What operating system is it running, right? What processes are running, right? All of these can be fed into that policy to be able to then give access or not give access.
Well, I think one of the challenges, again, where we kind of are talking around the challenge of Zero Trust is going from this system where everything is implicitly, inherently allowed to communicate with everything. I never understood why a workstation on a network would be sharing out a printer, for example. It doesn't make sense. Or have a share on it. Like we have servers that are supposed to do that, right? So from the perspective of a workstation, really nothing should be communicating and connecting to it specifically. And yet so few organizations actually have any sort of technical control or policy or even host-based firewall to prevent that. So we see lateral movement spread, we see ransomware spread everywhere. And so it sounds like from your approach and what you're talking about with Zero Trust, it's a matter of defining the policy, but is with Illumio, is the policy something that has to be manually defined, or is there an automatic kind of discovery component that makes it so that you can really get to a point where you have Zero Trust from all trust, I guess, today?
Yeah, I think that's a great question, right? Because it's, okay, so this all sounds great, right? Sounds very idealistic, and it's kind of like, this is what you teach in a university sort of security best practices course, right? But now you're talking about the practicality, right? So the starting point, and if you look at sort of the definition of Zero Trust, and it doesn't matter, choose your favorite sort of Zero Trust definition, one of the things it talks about is consistent monitoring, consistent visibility, right, over all interactions. And that's the starting point. Because let's assume that the majority of places where we're trying to put this in place are brownfield environments, existing production environments, right? So, and understandably, right, over time, because we have had that assumption of trust, right, we typically don't have the greatest understanding of how things interact in our environment, which is really scary, right?
It's true.
If you think about it, right?
That's the case.
If you think about it, it's the number of times we have customers who say to us, oh my God, like putting you in there, right? And we've just suddenly got this visibility into our environment that we've never had before, right? Which is both fantastic as a testament of value, but also really scary as a security practitioner. So that's where it starts, right? Understand how things are interacting with each other, understand the interdependencies, right? And then use that data to guide the security policy you want to adopt. And you have to have a goal, right? Let's kind of, that's really important. It's Zero Trust is not the goal, right? Zero Trust is an approach to security, right? What is your goal, right? And an organization may have a goal, say, okay, from my perspective, right, my goal is to ensure that if I detect ransomware spreading on the environment, I want to have a one-click ability to go and restrict that access. Okay, so that's your goal. So what you have is you maybe put in place some sort of policies, right? You kind of pre-define policies that, and let's say RDP is the transport for that ransomware, that you detect that from in your SIM, and you go and say, right, block RDP everywhere. That could be your goal, right? Versus, so you just need to understand where RDP is used, right? And maybe you have the usual exceptions, right? So define those rules, but visibility helps you do that, right? Equally, your objective may be, I have some high value applications, franchise critical applications that absolutely, right? These are the ones that if everything else goes down, is compromised, etc., because availability is just as important as sort of sort of integrity and confidentiality in the
Absolutely,
AIC
yes.
triangle, right? And particularly with cyber resilience, that's really come paramount. So if these are the things that absolutely have to keep running, then your focus may be on how can I reduce the implicit trust, reduce the sort of just allow access from anywhere to these things, right? And again, you use the data to guide that, right? And how difficult is it? Well, it really depends then on how much data do you need in order to take a good decision, right? If you have a good understanding of your application anyway, it could be that you need maybe a couple of weeks worth of data to say, I've absolutely captured everything. Here's the policy. I know this is golden. But equally, and we've had this experience where more sort of risk-averse organizations and industries want sort of 30, 60, 90 days worth of data, right? But you use the data to guide the security policy you're building, right? So that's, but you it's kind of, there's got to be that commitment to take that step.
And it sounds like this whole concept and approach, this methodology that is Zero Trust, as you've described it, is something that also, as a matter of a fact, where you're moving forward with this, you're getting the visibility and the context across these different platforms, be it VMware on-prem, be it Azure in the cloud, be it a VDI on-prem, be it VDI in the cloud, be it actual physical systems or things that they connect to. As that context switches and changes, that visibility rolls with it, so to speak, as well. And things like ransomware, you have better visibility into what's happening as well as controls around that, including lateral movement, because I would imagine in a true Zero Trust configuration, there is no real lateral movement capability, right? Because you're only saying these users can connect to these systems because they're allowed to and because of the policy.
Yeah, absolutely right. I think that's you have to have consistency, right? It really, if you have something, a security control that says, okay, I'll limit lateral movement in my physical server environment, right? But then if you move into the ESXi environment or into your cloud provider or in your campus network, we can't do much there. In reality, you're really not giving yourself much. Yeah, okay, you're protecting your physical servers, right? But once your workload moves, then what do? Right? It's essentially going back in time effectively from a security perspective. So it's really important that controls, as we build them, right? Particularly, I mean, network security controls are super important, and we'll always have things that are tied to the infrastructure. But we also ultimately, as we have things that are moving around, we need to push those controls much closer to the applications and workloads we're protecting, right? So that's why, like in the approach that we take from day sort of zero, from sort of founding principles, is we must provide our customers a way of being able to adopt this capability consistently as those workloads move around in their environment, right? So yeah, we're kind of like taking an infrastructure agnostic approach so that on-prem, physical, ESXi, cloud provider of your choice, right? Provide that consistency. And also, as you move from sort of traditional sort of like operating system based, right, workloads to containerize, to then when you start to, literally you're consuming sort of individual services, right? Even those need that control. So it's really being able to really provide that control regardless of how the users are, what components they're using.
That's fascinating. Thank you. I really enjoyed this discussion about Zero Trust. Certainly, I've been skeptical about Zero Trust. If you're still skeptical about Zero Trust, please visit securityweekly.com/LumioBH. And thank you very much, Raghu. I appreciate your time talking with me here.
Sean,
and thank you all for joining us as well. I'm signing off for myself at Black Hat on Security Weekly. Thank you very much for joining us, and hopefully we'll see you next year.
Hi, this is Jeff Mann, co-host of Paul Security Weekly, and I am not coming from Black Hat Live, but we did have one talk that we couldn't squeeze in when we were out there the other week, and that was mostly because the person I'm about to interview was so busy giving talks already that he just didn't have time and also might have had a little bit of trouble with his voice. So I am pleased to introduce you today, to Tomer Bar. Tomer is the VP for research at a company called SafeBreach. Tomer, welcome.
Thank you very much.
How's your voice doing? You all recovered?
Yeah, I'm okay. I recovered.
Very good. And I hate to ask this, but did you take a COVID test when you got home, and how did you score?
This is actually a good idea, but now it's too late. I think I'm okay.
Think you're okay? It's so hard to tell what we used to call con crud coming after the week versus, oh, now it's COVID. But enough of that. Black Hat was and DEF CON, what we call Hacker Summer Camp, was a very busy week for a lot of us. A lot of fun things happening. Tell us a little bit about yourself, Tomer, and tell us a little bit about what you were doing at Black Hat that got you so busy and had you lose your voice.
Of course, I would glad to do that. So my name is Tomer Bar. I started with computers when I was a child, but only for computer games. But after I finished my first degree in computer science, I joined the Israeli government and worked for the Prime Minister office for more than a decade. After that, I worked for more than 5 years for Palo Alto Networks. I manage one of their research security group and on the endpoint world and domain. And in the last 4 years, I'm running SafeBreach research. So at Black Hat, we had 3 talks at Black Hat. I spoke in 2, and we had another 2 in DEF CON the same week. So that was the reason that I lost my voice, but I will be glad to do it every year.
I'll tell you what, I did a couple of these interviews, but I was talking to people basically the whole week. I was losing my voice by Thursday or Friday. So, it happens. So what do we want to talk about? What's SafeBreach been working on? What were your talks about? What are you excited about right now?
Great. So I will start by explaining about SafeBreach. Actually, SafeBreach is the pioneer in a domain called BUS. BUS is for breach and attack simulation, and actually, it's a platform that allows large enterprises to understand their real security posture by simply running attacks in a safe manner, and they can see if their multi-million security controls that cost a lot of money can detect and block each attack. And of course, the ones that are missed are the most interesting, and they can have understanding of what happened, what went wrong, and how to fix it. And usually people ask, okay, so it's like a pen test. But I think that it's like there are similarities, but the main difference is that a pen test is usually done once a while, and BUS provide our customers to do it in a continuous process and to spot drift. So maybe last week it was okay and all attacks were blocked, and today all of them are still blocked. But let's say something happened today and someone, I don't know, there was a business need and someone changed the firewall rules to allow some connections and forgot to close it. And when the attack runs today, we'll find out a drift and we'll find out that it was missed and it was successful. So we'll understand in real time that we have a problem and need to fix it. So I think it's in general, this is how breach and attack simulation can help our customers. Regarding Black Hat, sorry.
Mm-hmm. Oh, go ahead.
Regarding Black Hat, we are monitoring different threat groups from all around the globe and understanding their mindsets, their techniques, and we mimic them as close as possible in our safe attacks. It's important because of course, you don't want to run the exact attack. You don't want to just run ransomware, real ransomware in customers' production environment, because it will harm them, and we don't want to do that. But the other way is also important, because if our simulation won't be close enough to the real threat, they might get some false feeling of security, because they will think, okay, all of the simulation were blocked, we are safe, but when the real attack will arrive, if it won't be close enough, the simulation, it might bypass their security controls, and we don't want this false sense of security. So this is very important. And beside that, we are doing original research, not just monitoring the things that are going in the wild. We are doing our own research on everything that is like important and significant. We just celebrated our 40 zero-day report on discovery. Of course, we work with all vendors in a responsible disclosure process. We report about our findings, sharing all of our finding and knowledge and how to fix the vulnerability. With Microsoft, leading EDRs, Dell, AWS, significant vendors. And after they fix the vulnerabilities and close them, then we release attacks, exclusive attacks in our platform, so our customers will be able to test if their environment are safe or not. So, for example, one of the research was called Defender Pretender. We call it that way because we analyzed Defender, a very sensitive process, the ones that are in charge of getting the updates, the signature updates. So let's say there is a new threat, a new ransomware, for example. So Microsoft analyze it and generate a signature to detect it. And in order that all of the endpoints around the world and server, or any Windows machine in the world will detect it, they will need to update it. And so each agent just download a file from the internet, from Microsoft Cloud, and then the update run, and then it will be able to detect the new threat. And we found out that all 6 files involved in this update process are digitally signed, which is very good. But we found out that Microsoft forgot to validate that all of the files are digitally signed in the entire in all the steps of the update. So we leverage this finding to update Defender with our own database, signature database, which was unsigned from the weakest user without permission, unprivileged user, and we're able to insert, edit, modify, or delete any signature. So the attack vectors are versatile. For one example, the simplest one is to remove all the signatures of a specific threat. So, for example, Mimikatz, we can remove all the Mimikatz signature. Mimikatz is a very common tool to extract user credentials from a process in Windows that store those credentials, and you can get all of the passwords of all users. So when we removed Mimikatz signatures, we can run the exact common in the wild Mimikatz, the known one, and bypass Microsoft Defender. We can also add our own signature and say this benign signature or set of characters are malicious. And we found out that all of the executables in Windows since the 80s, since the first version of Windows all around the world, contains a specific unique strings at the beginning of each executable. So we told Defender that this string, these characters are actually malicious. And after a few seconds, Defender tried to delete and succeeded in deleting all of the files in the operating system. So the drivers, the OS files. So it led to denial of service because Windows cannot operate without those critical files. And of course, you can also delete user data, administrator data, even from the weakest user. Let's say you want to delete all of the files that could contain a specific word, like news or SafeBreach or DEFCON, Black Hat, or anything like that. You can just add a signature that says Black Hat is malicious, and from that point, Defender will delete it. So this is just one example.
Interesting. Great. Well, I appreciate you giving us that recap of what you guys were doing at Black Hat. I want to back up a little bit and let's talk about the breach and attack simulation, just as a thing. I'm curious. You mentioned initially how it's similar and yet different from a pen test. I'm curious in terms of organizations that are out there and they're conducting business on the internet. What are you seeing as the best companies that can get the most use out of breach and attack simulation? Do you have opinions on, maturity level, when a company's ready for it? Are there things that they should be doing beforehand, before they do breach and attack simulation? Or do you see breach and attack simulation as some way better than or more appropriate than more or less traditional security practices, let's say, that some of us old timers might have been trying to educate companies for decades, and maybe they're getting it and maybe they're not. But just talk to me a little bit about the philosophy and the methodology of breach and attack simulation for a few moments.
Okay, so it's a great question. First of all, it's like fit to any customer in any industry. So it's not limited to financial or manufacturing. It will fit to all of them. But I must say that it usually fit more to large enterprise where they have staff that can run the simulation, and you have to prepare. It's like very easy installation. You just need to analyze and understand your environment, the different parts. So you have like the delimiter zone where usually all the application that needs web front. So let's say the web server and the file transfer protocol servers and the email servers, all the services that need access from the world will be in one zone. And there is the internal network, which usually is connected to the internet. So in some organization, there is another production network, and then the network itself is like divided into segments and different zones. So you need to have a good understanding of your architecture and where to put and install our simulator. The simulator is a basic agent that can play the two different roles. It can play from one side the attacker, and it can also play the victim. So after the organization, usually together with us, decided where to place those agents, they can decide which attack to run from each agent to the other. And let's say you are interested in the full kill chain, you can run attack from outside, from the cloud, from outside of the organization to the agent in the DMZ, from there attack from the DMZ to the internal internet, to the other computers, to other segments, and to the crown jewels of this organization. Sometimes it's the source code, sometimes it's like a formula, or sometimes it's the secrets of the organization or the production process, if it's an OT environment, where it's a production like producing electricity or other gas pipelining, water pipelines, or whatever. So to conclude, I think that it's like fit to any organization. It will better fit large organizations that have experts that can run the attack, and then after they run the attack from each point, they get the results, and they can understand the results and fix what needs to be fixed.
So we talk a lot on our show about breaches and various companies that have been victimized, and we often talk, and related to pen testing as well. We often talk about findings and remediations, and something that we've been talking about lately is we keep falling, at least I do, is we keep falling back on most of the breaches that occur out there. If you do a root cause analysis, it often comes back back to some sort of process failure. I'm sure you're familiar with the elements of data security being people, process, and technology. I'm curious as to how well your solution or in general breach and attack simulations address and look for not just the vulnerability or the misconfiguration that might be out in the environment, but how well does it track process failures? And then on the flip side, when something has been discovered, to what extent do you say, this system had a patch that should have been installed 6 months ago, but do you tie that to you really should look into your patch management process because something's not working? Can you speak to that a little bit?
Of course. I think that I will explain it by the difference between this new breach and attack simulation techniques to the old pen test and red teaming. So let's say there is let's say the attacker starts always from remote, and he's starting from point A. He will try to reach point B, C, D until Z. For traditional pen test, if you will fail from to get from A to B, usually you won't understand and get the understanding of what will happen if the attacker will succeed in going from A to B, right? Because you don't have any access to point B, so you won't be able to understand what could have happened from that and where are the vulnerabilities and gaps there. But because we have agents, and breach and attack simulation works like that, have agent in each point in A and B and C. So even if the attack from point A to B did not succeed, the attacks from B to C and so on will run, and you will have all the information. So after gathering all the information, without depending on if all of the previous attacks succeeded, then you can get a lot of data, and we gather all of these findings into insights. So that our customers can get insights on the eye level and not just on the technical details themselves, which they are also provided with, but they can understand if there are where are their main gaps. If it's the email security, the web security, their endpoint security, network security, cloud, container security, and so on. So they have a high level, and our remediation approach is to give them ability to close as much as security holes in just a single action as possible. So we'll give them an insight into, you have a problem in configuration of firewalls. The firewalls is not configured well because of reason ABC, and you need to fix it by changing this and that. So the mitigation are very specific, but also are in eye level.
Great. Well, Tomer, that's going to wrap us for today. I sure missed having the chance to sit with you in person. Maybe we can do it again next year. We'll just have to budget our time better. For our listening audience, if you want to learn more about SafeBreach, you can go to securityweekly.com/SafeBreachBH. That's for Black Hat. And for all the live interviews that we did and the one almost live interview that we did at Black Hat, you can go to securityweekly.com/Black Hat. So that is officially a wrap for Black Hat 2023. Thanks for listening and watching.